Alright guys, welcome to lesson 9.7. Today we're going to be talking about how to solve logarithmic equations. The first thing I want to talk about before we begin this is the domain of a logarithmic equation. So, in case you guys don't remember, what is a domain? A domain is all the possible values of x. Okay, so when you think of a log as a function, the input is usually going to be here in the argument place. Okay, now here's basically the idea here. Now I'm going to write this a little bit differently. Instead of using an x, I'm going to put argument here. Okay, but usually the x is somewhere inside of the argument. Okay, so what are the possible values of x? Well, a little while back we talked about how the argument has to be greater than 0. It can't equal 0 and it can't be less than 0. Anytime this number here is negative or 0, you get an undefined expression in your log. So the part where your x is located has to be greater than 0. Now that doesn't mean that x has to be greater than 0. It just means that the argument has to be greater than 0. And that will, since x is in there, that means that that will somehow put a restriction on what x is allowed to be. So let's go ahead and take a look at examples of how to find the domain of a log function. So let's say I had this log f of x is equal to log base 2 of 5x plus 10. Okay. Well, the argument 5x plus 10 has to be greater than 0. And since 5x plus 10 has to be greater than 0, we can solve for x to find out what x is allowed to be. So x is allowed to be any number that is greater than negative 2. Okay, we'll call that a. I'm going to go ahead and do a second example, however. Let me go ahead and erase this. Do b. How about this? Log base 5 of negative x over 3 is my function. Okay. So in this case, my argument is this. And we know that the argument has to be greater than 0, right? So how would I solve this? Well, the first thing you would do is you'd multiply both sides by 3, right? Because that will cancel the 3 out over there. Whatever you do to one side, you do to the other. So that leaves me with negative x is greater than 0. But here comes the next interesting step. We don't want that negative in front of the x either, so I need to divide both sides by a negative. Now, something interesting happens when you divide by a negative. When you divide by a negative, the inequality will switch around. So instead of x being greater than 0, it's going to become x is less than 0. Okay, so we might want to make a little note here. If we divide or multiply, but usually it's dividing. If we divide by a negative, we'll flip the arrow, flip the inequality around. So in this case, the domain for this function is, in other words, what are the possible values of x? The possible values of x, the domain, is that x can be anything less than 0. Okay? So I'm going to go ahead and throw an example at you guys to try out here. Change here. All right, go ahead and pause the video there and try those two problems and see if you can get the correct answer. I'm going to put the answers up now. So for the first one, you should have gotten that x is greater than -5. So x, you're allowed to plug in anything you want to for x so long as it is greater than -5. For the second one, you should have gotten that x is less than 3/2. So that means you're allowed to plug in anything that is less than 3/2. And you might notice that the arrow got flipped, and that's because in the process of solving this equation, you had to divide by a negative number. And when you divide by a negative, the arrow will reverse, the inequality will reverse. Over here, the double negatives cancel, and you get that. Okay. Now, something I want to warn you about is it's the number next to the x. If you're dividing by that number and that number is negative, that's when you reverse it. It does not matter what this number is. It only matters what number you're dividing by. Okay? All right. Go ahead and move on to another topic. We're going to actually start solving a problem here now. So let's go ahead and take a look. So we're going to call this example 2. Go ahead and write that down. And our job is to solve for x. So, and this is, I'm going to start off with this problem because of two things. First of all, it's pretty easy. Second of all, it kind of demonstrates why it's important to find your domain first. All right, so let's go ahead and begin here. The first thing I want to do is I'm just going to actually start by solving it first. Now, this is one type of log equation that we're going to solve. We're going to solve a few different types. But what makes this one special, and you might want to make a note of this, is that there is a log on both sides. In my opinion, these are the easiest ones, when you have a log on both sides of the equation. I've got a log on the left side, I've got a log on the right side. What makes these things so easy is that you can just take the log off both sides. Okay? Anytime you have an equation, whatever you do to one side, you just do it to the other and you're good to go. So I've just took the log off the left side, so I can just take the log off the right side. And once you've done that, you're left with a pretty basic equation that we've learned how to solve since Algebra 1. So let's go ahead and solve it now, just using our Algebra 1 skills here a little bit. We're going to start by adding the x to both sides to cancel that one out, right? And that's going to leave me with -10 equals x plus x is 2x. Divide both sides by 2. And that leaves me with -5 equals x. However, before I circle that and call it my answer, so I'm not going to circle it yet, we have to check our work. Okay? Is this answer allowed? In other words, is that part of the domain? The answer is no, it is not, and I'll show you why. Let's back up a little bit, and I'm going to find my domain really quick. Erase these. Now I've got 2 logs, so technically I would need to find the domain twice. We have -x minus 10. That needs to be greater than 0. And we also have x, and that needs to be greater than 0. Now for the first one here, I'm going to add 10 to both sides. And then I'm going to divide both sides by a -1. Since I'm dividing by a negative, I will need to reverse it. So my answer needs to be less than -10. And my answer also needs to be greater than 0. Now, first of all, you guys may notice that's not even possible. It's not possible for a number to be greater than 0 and less than -10. But remember the answer we got was -5? Well, -5 is neither one of those things. It's not greater than 0, and it's not less than -10. Okay? Now, you don't really need to do it that way. Here's what I'm going to suggest you guys do instead, though. Okay? Once you get an answer, my suggestion to you is going to be to just check your work. Okay, check and see if you're allowed to plug that number in. So for instance, we got -5, right? So what I'm going to do is I'm going to plug in the -5 for x. Now on the right side, the double negatives becomes positive, and 5 take away 10 is -5, right? Forgot a little bit to do there. Okay, well, see how those two sides are equal to each other? That's cool, but here's the problem. Your argument cannot be negative or 0. So here's the deal. Whatever answer you got, and we got -5 as an answer, right? If you plug that in and it makes the argument become negative or 0, we're going to cross that answer off and we're going to say no solution. Okay, that was a smudge. I'm going to get rid of that. No solution is the right answer. I want to do another example with you guys really quick just to drive this problem home. Okay, so let's do one. Okay, so we'll call this example 2 part B, right? Same directions. We're just going to call it part B. All right, so let's go ahead and solve it. The first step is to cross the logs off. The next step is to solve for x. Cross the logs off, solve for x. And I get x equals 1. But we have to check our answer when we're done. What would I get if I plugged in x equals 1 for x? What if I plug my answer in up here for x? Here I get log 2. I forgot to write the word log here, silly me. And over here I get log 2. Now look at your argument. Is that allowed? Did this number come out to be positive or did it come out to be negative? Well, it's positive. So that's a good answer, that means. That means that x equals 1. But sometimes you will get an answer that when you plug it in, it makes this piece become negative, and we're going to throw that number out and say it's no good. So we have a 3-step process. Okay, step 1 is to cross off the logs. Step 2 is to solve for x. Step 3 is to plug it in. And remember, we're not allowed to have 0 or negatives after we plug it in. Those are not allowed. If you get a 0 or a negative, then you cross it off and you say there's no solution. Okay? So I'm going to let you guys try a sample problem. Go ahead and try that one there. Pause the video. So for this problem here, you guys should have first dropped the log off. Then you should have solved for x using your Algebra 1 skills. And we get x equals 5. So we did step 1, crossing off the logs. We did step 2, solving for x. But now we've got to check our answer. We've got to make sure that answer is actually allowed. So if you were to plug in 5 here, what would you get? You plugged in 5 here. 2 times 5 is 10, plus 4 is 14. That's a good answer. Same thing over here. If you plug in 5, 5 times 4 is 20. Take away 6 is also 14. That's a positive number there. And anything that makes your argument come out positive is a good answer. So we're going to circle that and say that that is our answer. This is part of the domain since it didn't make our argument negative. So we're going to go ahead and move on to a new type of problem now. So remember, we're going to look at a few different types of equations. This type of equation is where you have a log on both sides. Okay? That doesn't always happen, though. There are exceptions to that. So let's take a look at some other types of problems. Here to number 1. Now, before we start with number 1, I want to remind you guys of a property we talked about. So don't write this down yet. Let's write down a reminder first. Here's our reminder. Our reminder is that we had this property a while ago, right? A to the power of log base A of x equals x. Kind of like this and this cancel each other out, okay? We're going to use that rule to solve these equations. So I'm going to call these ones the basic examples. Okay, a basic example is when you just have one log and the number over here. Okay, so how do you solve a basic example? The first step is you want to identify what the base is. In this case, the base is 4. Now what we want to do is we want to make this a power of 4. So here's what I mean by that. I'm going to write a big 4 here, and that whole thing is going to become a power of 4. Now I'm allowed to do that. I'm allowed to make this side a power of 4 if I also make this side a power of 4. Now why would I do that? I would do that because of that rule we talked about earlier. This cancels this, and we're left with just the x. 4 to the third power, that means 4 times 4 times 4, which is 64, and there's our answer, and we're good to go. Okay? So, the first step is to make this side a power of that base. And that process has a word to it. It's called exponentiate. So step 1 with the basic examples is to exponentiate. Step 2 is to cancel out. So we crossed those off, right? And we're left with this. Step 3 was to simplify. Now, technically, you should be checking your answers to make sure that it doesn't make the log negative. However, I will tell you, it will never happen with these types of problems. The only type we're going to talk about today where you'll end up with an answer that doesn't work is with the ones that we did in example 2. Okay, so I wouldn't worry about it too much. Let's do a guided practice of this, and then I'm going to let you guys try another one on your own. Okay. Okay. So we'll call this one guided practice 3. This one, what I'm going to encourage you guys to do is just try to predict what I'm going to do before I do it. So for a moment, take a look at the last example that we just did. I want you guys to recognize this is a basic example. It's just one log with a number on the other side. Okay, that's a basic example. So looking at the last example we just did, what's the first step? See if you can do it. Pause the video and write just the first step. The first step was to exponentiate. And what that means is you take that base and you make this side a power of that base. But whatever you do to one side, you do the other. So I will also make this side a power of the same base. Okay, next question. What's the next step? Look at your last example and see if you can predict what the next step will be. The next step would be to cancel. So this cancels this. And what we're left with then is this. All right, now sometimes you end up with a really ridiculous expression. Like I was looking at some examples and had like 12 to the 4th power. That's a huge number. My guess is if you see something like that, they're just going to leave it as that. They're not going to actually work it out. They're just going to leave it the power. However, this is not a ridiculous one. This is one we can actually do. Now, first of all, what is 11 to the 2nd power? Think about that for a moment. 11 to the second power would be 121, right? However, it's not just 2, is it? It's negative 2. You guys remember what negative exponents do? Negative exponents make reciprocals. So yes, 11 to the second power is 121, but since it's negative, it's going to be 1 over 120. So if it's, small numbers, which believe it or not, hundreds are kind of small when you're talking about exponential numbers, they're just going to ask you to do it probably all the way. But if you get something weird like m equals 12 to the 9th power, they're not going to ask you to work that out. The number's huge, so you're just going to leave it like that. But anyway, there's your guys' examples. And technically, yes, we should check to see if our answer makes the argument negative, but I promise you they will not, unless they're the ones that have a log on both sides, okay? Let's go ahead and have you guys try this one here. Go ahead and pause the video and see what you get. There you go. So step 1, I exponentiated. Step 2, canceled. Step 3, simplified. All right, we'll move on to a fourth example here. Surprised into that already. Okay. I guess that'll probably be it. This will be our last example for the day. All right. So in this particular problem, we have a lot of extra stuff. Okay. We have, remember how we talked about the basic example? The basic example is when you have a log with an x, and then there's just a number over here, right? That's what I would call a basic example. Now this example is what I'm going to say, I'm going to call this one extra numbers. So let's go ahead and title this as example 4. Once again, we're solving for x. And we're going to call this the extra numbers problem. And here's what I mean by extra numbers. Instead of just a log with an x and a number, we have extra stuff inside there. It's not just x in here now. It's a v and a 3 and a negative, and also there's a number out here. So there's extra numbers. How do we deal with log problems that have extra numbers? Okay, well the first step is to get rid of the numbers that are outside of the log. So on this side of the equation where our log is located, what number is not inside the parentheses of the log? Well, it's the negative 4. We need to get rid of that negative 4. How do we do that? You're going to add it to both sides. That will cancel that out. And now we're left with just a log. Now that log has some extra numbers inside. That's what we're left with. So step 1 is to get rid of outside numbers. Okay? Step 2 is going to be what we did last time. It's going to be to exponentiate. So what's the base we're working with here? The base is 9. So I'm going to make this side and this side powers of 9. So this is going to be 9 log base 9 of negative v plus 3 equals 9 to the 1. So this side became a power of 9, and this side became a power of 9, right? The next step is to cancel. On the left side, the 9 cancels the log 9, and we're left with this. 9 to the first power is 9, so I'm just going to write it like that. And from there, you should be able to just solve. So I'm going to minus 3 first. That's going to leave me with negative b equals 6. And then I'm going to divide both sides by a negative 1. And I'm out of space, so I'm going to write my answer over here. But the negative 1 cancels, and 6 divided by negative 1 leaves me with negative 6. And once again, although technically you're supposed to check your answer, I will say once again, you're not going to have to. The answer you get here will always be a good answer. It's never going to be outside the domain. The only ones that will be where you can get a no solution are the ones where you end up with a log on both sides. Those could give you. But let's review. Steps are: get rid of the outside numbers first. Step 2, exponentiate. Step 3, cancel, step 4, solve. Okay? That's how you solve for logarithmic expressions with extra numbers. Let's do another example like that real quick. All right, go ahead and call this a guided practice. All right, so step 1. What's step 1? First of all, you guys know this is what type of problem is this? This is a problem where you have extra numbers. So how do we deal with extra numbers? Well, the first step was what? It was to get rid of the outside numbers. Now, we have what numbers are outside of the log? Hopefully you guys are seeing that it is the -3 and the -8. So we need to get rid of those first. Now, the first thing is this problem is a little bit different from the last one. Okay, I'm going to show you guys how to get rid of the outside numbers first. Okay, on this problem, the first thing you're going to do is you're going to add the 3 to both sides like this. Oops, mark there. Add the 3 on both sides. And the reason I'm going to show you this one and not just let you guys try is because a very common mistake I see students do at this point is they would combine these. Like they would do -3 minus 8, and you can't do that. This 8 is being multiplied by the log, so these are not like terms. You cannot combine them. So the first step is to add the 3 on both sides. Now I'm going to ask you guys to think for a minute. This is -8 times log. How can I get rid of that -8? Think about it for a minute. Maybe even try it if you want. Pause the video if you need to. So here's a common mistake students would make at this point is they would add the 8. But here's the problem. That's not how you cancel a -8 when it's being multiplied with something. What we're going to do is we're going to divide both sides by a -8. Okay? So the number that's right next to the log is going to be divided. That will leave me with log of -4b plus 1 equals -1. Okay? What's the next step? See if you guys can do the next step. Pause the video and see if you can do the next step. The next step would be to exponentiate. Now, what makes this one a little bit tricky is the fact that there's no base, is there? But we learned a while back that when there's no base, it's 10. So if you wanted to exponentiate, you would be using 10 as your base. Log base 10 of 4b -4b. And 10 to the -1. All right. What's your next step? Next step would be to cross off those. And that leaves us with this little expression here. -4b plus 1 equals 10 to the -1. Now my next question to you is, what is 10 to the -1 power? Take a moment and see if you could figure that out. 10 to the -1 would be 1/10. Now nobody likes fractions, right? Mr. Bailey's taught us many times how to get rid of fractions. What did we learn about that? What we do is we multiply everything by that little denominator, right? Those cancel, and let's see what we have left as a result. 10 times -4 is going to be -40b. 10 times 1 is 10. And over here, since the 10's cancel, we're just left with 1. And from here, I'm pretty sure you guys would be able to solve it. So pause the video and see if you can solve it. Next step would be to minus the 10. Next step would be to divide by -40. Final answer is 9/40. Okay, so once again, we're going to get rid of the outside numbers first, which took 2 steps actually. And then we exponentiate, and then we cancel, and then we solve. Okay? So let you guys try one of these real quick. There's one for you. Pause the video here and I'll put the answer up. Alright guys, so step 1, I will circle in yellow here for you, is to get rid of the outside numbers. So the first thing I did was I subtracted the 2 and divided by 4. Step 2 is we would exponentiate both sides. And step 3 is where I crossed off and canceled out the log. Finally, we have step 4 over here, which is solving for x. Notice at the end I reduced. You need to reduce it. And technically, yes, step 5, you need to make sure your answer won't make the argument negative, but I've promised you, you will never need to do that unless it's the problems where you have a log on both sides. So we've talked about 3 types of problems today. Well, kind of 4 really. We talked about how to find the domain, take the argument, make it greater than 0, and solve. That tells you what x is allowed to be. Another thing that we talked about doing today was our first log type, which we have a log on both sides. Just cross off the log and solve. But for those, it's very important that you make sure that your answer does not make the arguments negative or 0. The next thing we talked about was a basic log equation where you just have a letter on the left with your log and a number on the right. The last thing we talked about, though, was problems that have extra numbers. Numbers that are outside as well as inside, and so we have a little bit of extra work to do. So we talked about 3 different types of log equations, and we also talked about how to find the domain. So we talked about 4 things today. Now in our next lesson, we're going to talk about more types of log equations, which are the ones you see down here. But for today, we're going to stop with those. Okay, so happy working to you, and we'll see you guys later.